So, all molecules, are you with me?
Yes, you heard someone.
Natalie, Billy, are you all with me? You girls with me? All molecules have what kind of energy in them? Any chemical substance. Potential energy. All molecules have stored or potential energy within their bonds. During a chemical reaction, some bonds break while others are formed. In order to break this bond, do I need energy or will it release energy? Do I need energy or will it release in order to break a bond? I need. Is that right? I need energy. So it takes energy to break a bond. If you have to provide energy to break a bond, if you have to give heat energy, what kind of a process is it? It's absorbing. So is it endo or exo? It's endothermic. And when the bond is formed, all right, and the reaction releases energy when bonds form. And so because it releases energy, what is that process called? It's called an exothermic process. And chemical reactions, the starting chemicals are known as reactants, and the ending chemicals are known as products. In order for a chemical reaction to occur, a certain amount of energy must be added to what? What should get the energy in order for you to start the reaction? Reactants must be added to reactants. No, must be added to start, to start the reaction. In order for a chemical reaction to occur, a certain amount of energy must be added to start the reaction. This added energy helps start the what of the bonds? The breaking of the chemical bonds. So that new ones can be formed. What is this energy known as? This energy is known as activation energy. What is this energy known as? It's known as activation energy. The reactants form. Can you flip the page to the second page, please? Can you go to the bottom picture? Can you go to the bottom picture? So can I borrow that? Now, so what is happening here? These are the reactants. You gave that energy. What did they make? What do they make? What? Light? Daniel, where is that coming from? What are we talking about right now? So, when the reactants gain energy, what do they make? What is that called? It's called the activated complex. Write that down. They make the activated complex, which has more energy than both reactants and products. And products. Now, before we complete this, I'm going to go to the bottom. Okay? Say we are graphing a reaction. Guys, the class is very talkative. Can we focus? These are easy concepts, but you can make careless mistakes if you don't understand it thoroughly enough. Alright? So, say we are plotting time or how the reaction is progressing, time in seconds, or the reaction progress, however you want to call it. All right? Say the y-axis is the energy of the reactants and the products. All right? We're now going to divide it into equal parts, 10, 20, 30, 40, 50. 10, 20, 30, 40, 50. Say energy is in kilojoules. Are you with me? So, for the sake of simplicity, all right, let's say all my reactants, which is what? A plus BC, all my reactants have a total energy of 20 kilocalories. Are you with me? A plus BC are my reactants. Correct? What are they? They are my reactants. My reactants have an energy of how much? 20 kilocalories. Are you with me? Will the reactants automatically become products? What should you provide the reactants with? Activation energy. Is that right? So let's say, how much activation energy do you want to give? How much activation energy? 30 will make it all the way to the top, 50. So where does activation energy start? From 0 or from the reactant? From the reactant, he wants to give it 30 kilocalories. So E activation, EAC, all right, is 30. Are you with me? Now what will happen? It will reach the top, and what will it form at the top? What will it form at the top? What is that called? Activated complex. It will make the activated complex, and then what will happen? Now it's very high in energy. It will roll down and make the product. Some of them will become reactants again. Is that right? It can roll down either way. Is that right? So now, let's say the product, what is the product energy? 10. What is the energy of the product? 10 kilocalories. So this is the hill, right? This is called a potential energy diagram. It gives you the energy of the reactants and the products as they go through the reaction.
What did you write in the first four lines?
That is A plus BC or its reactants. Now, what is heat of reaction? So what is the heat of the reaction? Delta H, triangle H, is heat of reaction. Heat of reaction is always heat of product minus heat of reactant. What did we say was the heat of the product? What was the heat of the product, guys? 10. What was the heat of the reactants? Where did we start the reactants with? 20. So what is the difference? Negative 10. Now tell me, finally in this reaction, as reactants have become products, have you released energy or have you gained energy? Release. If you release energy, is this an exothermic or an endothermic reaction? This is an exothermic reaction. So in an exothermic reaction, what is the value of delta H? It is positive or negative? It is negative. Or heat is a product. Heat is a product in an exothermic reaction. Do we understand this? All right, so let's draw another graph. Let's make that 10, 20, 30, 40, 50. Tell me energy of reactants. What should I choose that to be? Justin, what should I choose the energy of reactants to be? Huh? 20 again? All right. He wants the reactants to be 20 again. Anybody tell me what is the activation energy? Give me a number. 10, which means it only increases. Let's do a little bit more so that we can see a graph. 20. So 20 is the activation energy. Okay? I'm going to give you the energy of the product. I'm saying the energy of the product is 30. What is the energy of the product? 30. So it goes through this graph like that. So overall, what is the heat of the reaction? It is 20 minus 10. Product minus reactant, it is plus 10. Is that right? Overall, did this reaction gain or lose energy? Gain. Therefore, this is an endothermic reaction. In an endothermic reaction, products are higher in energy than reactants. Let's go up and let's write a few things down here. What do you want to say? If the products of the reaction have blank potential energy value than the reactants, more or less, what do you want to say?
More.
Okay. If the products have more potential energy, the reaction has? What has happened? If the products are more in energy than the reactants, has it gained or lost? It has gained energy. If it has gained energy, is it exo or endo? Making it an endothermic process. And the other one is the opposite. If the products of the reaction have less potential energy, the reaction has lost, making it an exothermic process. The heat of reaction, written as triangle H, is the difference in energy of the products and the reactants. If this value is blank, the reaction is said to be blank. If this reaction is positive, the reaction is said to be endothermic. While if this reaction is negative, it's said to be exothermic. All right, we are going to go to the second page here, okay, or your third page, and we're going to answer questions starting with Katie at the end. So which letter in the diagram represents total energy of the reactants? Starting from 0, what is the total energy? Which letter? A, very good. Becca, total energy of the product? E is correct. Michaela, total energy of the activated complex from 0. That is correct. The activation energy, even. That which you give to your reactants, starting with your reactants for the reaction to happen. B is correct. So, heat of reaction, Megan, it's product minus reactant. So, here is the product, that is the reactant, that difference is the heat of reaction. X, that is correct. Ali, is this reaction exo or endothermic? It is endothermic. Okay, going down. Now, imagine this to be a reverse reaction. We went through the forward reaction. Now think that Z is becoming X plus Y. Are we good? So having said that, what is the activation energy for the reverse reaction? If this is my reactant, Natalie, what is my activation energy? This is my reactant now. I have to activate it. What is my activation energy? E is the total energy of the reactant. I have to increase its energy. That is correct. It is D. All right? Hilly? Now it's the reverse reaction. What is the heat of reaction? Remember, this is the product, that is the reactant. What is the heat of energy of the reaction? This is the product, that is the reactant. The difference between the reactant and the, it is F, but it's going to be negative F because it's a reverse reaction. Liam, is the reverse reaction exo or endo? That is correct. The reverse is exo. What is a catalyst? So you have learned that catalyst is something that speeds up a reaction. That's okay for biology, not for chemistry. In the sense that you really have to understand what does a catalyst do. All right? So this is my, say I'm going back to the forward reaction. This is my reactant, that is my product. A catalyst will not touch the energy of the reactant or the product. Instead, what does a catalyst change? What does it change? It changes the activation energy. What does a catalyst do? A catalyst lowers the activation energy. By lowering the energy required to become a product, more of them are able to cross that bump. Does that make sense? It's a lower hill now, so more reactants will become products. Does that make sense? That's why we say it speeds up a reaction. By the way, does a catalyst impact the heat of a reaction? Does it impact F? No, know that. Catalyst will not impact heat of reaction. Catalyst does not impact delta H or heat of reaction. All right? So having discussed these things, it's Gabriel's term. If a catalyst were added, would the activation energy, what will happen to the activation energy? Decrease. Moving on to Kevin. If a catalyst are added with the heat of reaction, it's going to remain the same. Do you want to go and try this problem yourself?
Why would it remain the same?
Well, let's go back and look. This is the catalyst. Did it? Oh, wait, what happened? Right? This is the catalyst. Did it impact F? Did it impact heat of reaction?
Oh, I thought
What does the catalyst impact? So the heat of reaction will stay the same. Are we good? Everybody's tired. It's like it's a long lecture class, right? How much time do you have? 4 minutes. I wanted to do redox also. Too bad. I've given you. It would be nice if you kids can look up redox on your own and come back to class. I might not do. So guys, so next class, are you listening? Next class, you're going to be doing a lab. What do I want you to review for next class primarily?
predicting products.
Predicting products. There is a video on Blackboard, I think, on predicting products. Is that right?
Yeah.
Go through predicting products next class. Are we good? And all material taught today will be quizzed on Tuesday next week. Okay, I'm going to record this one also.